If a rugby field is situated in such a way that the north-south direction, so this is a north-south rugby field, two players, A and B, are running at constant speeds of 12 meters per second and 11 meters per second respectively. So we've got 12 meters per second and 11 meters per second. They cross the halfway line at the same time, 25 meters apart from one another. So there they are, they're crossing the halfway line, they're 25 meters apart. The angles that they are running at is 60 degrees and 80 degrees respectively to the halfway line. First we need to calculate the components of both of these velocities. So what we're going to do is the following. First we're going to take a look at the 60 and the 12, and so we need to construct a vertical and a horizontal component, vertical and horizontal component. If I'm working in the first triangle, I have an opposite side to the 60, which is over here, an adjacent side, and the hypotenuse is 12. So let's work out our vertical and our horizontal components. Firstly, horizontal component is going to be cos of 60 is equal to the adjacent side over the hypotenuse. So it is going to be equal to a horizontal, let's say, over 12, and a horizontal will turn out to be equal to 6 meters per second. The vertical is going to be using the opposite side, so its sine of 60 degrees is equal to a vertical over 12, and a vertical turns out to be 10,4 meters per second. The next one that I do is on the next triangle, I've got 11 as a hypotenuse, I've got a vertical which is opposite to the 80 degrees, and a horizontal which is adjacent to the 80 degrees. So I'm going to go cos of 80 degrees is equal to B's horizontal component over 11. And I find that B's horizontal component turns out to be 1,9 meters per second. And the vertical component, sine of 80 degrees, is equal to B's vertical component over 11, and B's vertical component is equal to 10,8 meters per second. Then asks me, who is going to cross the quarter line first? In other words, who is making the fastest vertical progression? Who is going vertically forward faster? And it turns out that B is making more vertical progress than A is making. B is making much less horizontal progress, but in terms of getting across the quarter line, 10,8 is greater than 10,4. When I take a look at a diagram like this, I've got a mass piece hanging in the middle, two strings over frictionless pulleys over there. What you need to realize is that a string, in terms of tension, has to have the same tension all the way through the string. So no matter what, we're going to land up with the identical tension throughout the string. The vertical component of each force acting on the object. So I'm going to worry about this force over here and this force over here, and I'm going to get the vertical component of both. It turns out force 2 is equal to 20 newtons and force 1 is equal to 30,6 newtons. I then take a look at these angles and I get the vertical component by saying I am interested in the adjacent side. So I'm going to use cos. So for F1, the vertical component is going to be equal to, I'm going to say cos of 30 degrees is equal to my vertical component of F1 over 30,6, and for the other one my vertical component of F1 is going to turn out to be 26,5 newtons. And cos of 50 degrees, now looking at the vertical component of F2, but this time dividing by 20 newtons. Why? Because 20 newtons is the hypotenuse for F2. And the big trick in this one was really just to transfer this downward force in the rope into a tension force on those two angles over there. And I then land up with the vertical force of F2 being equal to 12,9 newtons. Both of these are upward forces. So when they ask me for the resultant vertical force, I am going to say upwards 26,5 plus 12,9 newtons are acting, and that turns out to be 39,4 newtons. When 39,4 newtons is acting upwards, then what must, if it's all standing still, what must the downward force be? It's also 39,4 newtons. So what I do is I say, if I'm looking for the mass of the object, I know that mass times gravitational acceleration is equal to weight. I've got the weight, it's 39,4. I've got gravitational acceleration, it's 9,8. So I can work out the mass. And the mass turns out to be equal to 4,02 kilograms.